Good morning, everybody. Thank you so much for coming out this morning. Hope everybody's been coffeed well and is awake. If anybody needs any seats as people fill in, there's some up here. But yeah, like he said, my name's Tuckerman-Lee. I'm a site reliability engineer at Airbnb. And indeed, there is a wonderful launch going on right now. Hopefully, without any hitches. I luckily got a sneak peek of our APM dashboard just then to feel more comfortable. So who am I? Maybe why are you here listening to me? Site reliability engineering at Airbnb is different than maybe some companies. We're the team that's responsible for building tools and processes that other teams use to manage their incident response and reliability needs. At Airbnb, I've also worked on our risk and trust team, ensuring that everybody is having a good and trustworthy time on Airbnb, not dealing with any issues. And that's where I first started working on the reliability needs of our platform. So this morning, some things that we're going to go through is first, I want to talk a little bit about our DevOps and incident response teams and processes at Airbnb. Then I want to talk a little bit about the future of our processes and something that I'm calling people first on-call and how we're thinking about evolving our on-call rotations. Then we're going to do a little dive into the tools that we use at Airbnb to make sure that our users are having the best time that they possibly can. I want to do 2 walkthroughs of some real past incidents that we've had at Airbnb. And then lastly, I want to talk a little bit about that conference that's going on right now and how we've been using New Relic to make sure that it's going off as well as it can. So first, I want to talk about DevOps and SysOps. So everybody is familiar with the old school idea of developers and operations, a team that's building products for your company, throwing them over the metaphorical wall to your operations team who's responsible for managing and scaling them. And we all know that there's problems with this situation. If there's an incident, you have your operations team who's fixing it, not necessarily fully aware of maybe the intricacies of the actual implementation. If there's changes that need to be made, there needs to be communication back and forth. So the industry came up with DevOps, which is this wonderful, nice, short little term that we all like to throw around a lot. And there's a lot of great benefits to it. You have fast velocity of changes. If the team that's doing the deployment is also the team that's making the changes, they're able to prioritize when things go out and make sure that the releases are going out quickly and smoothly. You have ownership. It's no longer, I need to build a product with these features. I don't care about reliability. I don't care about scalability, because you're the one that's going to be woken up at 3 a.m. if it goes, if a pager goes off. And then it also encourages automation. If your engineers are also working on deployments, you start building better tooling and processes around automating your problems. But DevOps isn't necessarily perfect. One question might be is, who is your DevOps team for your AWS integration, if there's an issue there? Or if you have an external service that you're relying on. If those kinds of issues, if you have individual teams owning problems, like how do you filter that down to who's going to deal with it? Also, service-oriented architectures are a great thing to work towards. I'm sure it's something that we all would like to get to. But I don't know about your companies, but at my company, we also have something called the monorail, if you can imagine what that is. And so there are teams, right, that are working on services, pushing features that are interconnected with other teams' features. So if I push a change to service A, and that starts causing breakages in problem B, are these 2 teams going to start working on problems separately, investigating it? How do you combine forces and share that knowledge? And that leads into incident management and investigation. You want to make sure that when there's incidents, that everybody's following the same process, that you have good follow-up, that you're able to understand user impact. And these are skills that are different than what a typical DevOps engineer might build. These are things that you get through trial and error and going through the fire, so to speak. So at Airbnb, this is dealt with a team called SysOps. But in order to talk about SysOps, I want to talk a little bit about the history at Airbnb. So Airbnb was founded in 2008. And around that time, as we started growing, we needed to hire our first SRE. And this was a traditional SRE, you're going to keep the site up kind of guy. So he's on call 24/7. And when I say he, I mean one. His name was Davide, and he was the SRE. So this doesn't necessarily scale. As people build more services, as Airbnb becomes relied upon by more and more people, you imagine the situation, you're getting off of a plane, you open up your Airbnb application because you just got in your taxi and he says, where are you going? And you look down and you get a 500. That's not a really great experience. So this becomes more and more important, and it becomes more and more difficult to understand the full stack. Also, one person on call 24/7 is not maybe the best work-life balance you could possibly get. So we turned to volunteers. There was a weekly engineering meeting. He got up and was like, hey, can anybody help me out? Anybody want to go on call with me? And a few people volunteered. They understood the importance of this and saw it as an opportunity to expand their understanding of the stack. And that was the first meeting of the SysOps team, was at that engineering meeting. They met afterwards to plan how they were going to do the PagerDuty rotations. Since then, it's gotten a little bit more formalized. We're now a group of engineers that volunteer to go on call, and you get a hat now. So there's always benefits to doing it as well. So what does this look like? Like I said, it's a volunteer group. It's made up of both front-end and back-end engineers. It's also made up of engineers that work on our product and engineers that work on our infrastructure. And there's even engineering managers on this team as well. So you might ask, how do you get a group of people that don't necessarily have the experience to go on call? And so we also provide training. And this is training not just to somebody who wants to go on call, but to anybody in Airbnb who wants to learn more about incident response, incident management, and how we tackle the problem at Airbnb. There's also pizza. So that's also a great way to get people to come out to a training. This team also is the owner of Airbnb.com's reliability and maintenance at any given time. Their job is to keep our site up for our users. And because of that, they have a lot of ownership around the process. So this is a team that, when things are going wrong, they're able to step in. We have a single point of escalation if there are issues that you can get in the room. And so this is how you go from a model, which is great, where individual teams, the pain is being felt where it's supposed to be felt. But when you have large issues that are impacting your users, you're able to take control of the situation. And we do that through the incident command model with incident commanders and operators and SysOps, and we go through that process in the training. So what does this look like today? We have 25 engineers who are on call for our primary rotation. There's 4 different levels of the rotation, so there's also more people that are involved, but I wanted to call out these 25 specifically. These are the men and women who get woken up at 3 a.m. if our users aren't able to book. There are 50 people across the entire org that are part of SysOps, that attend the meetings, are somewhere on that escalation chain, or are involved with decision making. And then when I talked about the training, over 1/3 of our team on engineering has gone through this training. And so we try to make it accessible to any engineer. We do it multiple times per year. And this is also training that, because we have a centralized team that does incident management, this is a model that we like other teams to follow. And so this is great, a great learning opportunity, even if you're not going to join SysOps, to bring back to your team for implementing best practices. So you might ask, how does this work organizationally? You have a team. They don't have an engineering manager. They don't have a product manager. They're volunteers. How do you make this work inside of your organization? And I think it starts with culture. You have to understand that reliability matters to your product. And at Airbnb, this gets across, like I said, because if the site goes down, not only are we losing money, and it's a bad experience for our users who are trying to book, but it's a bad experience for our hosts and guests who have trusted us to make sure that a situation that it could be kind of scary is going to be okay. And that is something that 10 years ago from now, I don't think anybody would have thought it would have been really okay to let somebody come into your house that you've never met before and sleep in your bedroom. So we're really selling trust. So making sure that our site is up and available so people feel that trust is very important. At the same time, we have to understand that it's okay to make mistakes. And this is something that really needs to be, I think, top down, is that your management needs to understand that if you're going to move fast, there's going to be mistakes. And that's okay as long as you're learning from it. And so I'd like to call out the blameless postmortem that was espoused by Etsy. They have a great blog post about it. And I think going after this model where it's okay to make mistakes as long as we're learning from them and we're implementing fixes or mitigations to make sure that it doesn't happen again, or if it does, that it won't be as bad. And we take that that kind of grows into the learning opportunity on SysOps is that when issues do come into play, we give people a lot of ownership, but we also give them a lot of tools to make them feel like they're going to be capable of fixing it. So it's seen as a learning opportunity to understand our growing stack. As we become a larger engineering company, and I'm sure many of you have seen this, you've gone from a small group of people that are the engineers for everything to more siloed teams working on their services. And so teams like SysOps, this is an opportunity for someone to grow their influence, grow their understanding of the stack, and maybe get to work on things that they wouldn't otherwise get to work on. This is only OK if there's good tooling and processes around this. And so that's where the site reliability engineering team comes in. So when you do have SREs, these are people that have gone through training, have industry experience in how you're going to do incident response. So as opposed to making them constantly on call, constantly interrupted, their flow interrupted with fires, instead isolate them from the actual on-call rotation, and then they're able to spend their time working on tooling and processes to make it better for the entire company. And lastly, culture is something that is really fundamental to Airbnb. I think it shows through in our product, but it's something that is very important to us. There's also some microcultures inside of Airbnb, and engineering is no exception. And the term that's thrown around a lot is own your own impact. It's the name of this talk, and it's said to each other and Slack all the time, own your own impact. And I think having a mindset like that, where you need to take responsibility, is how you grow into an organization that can support a volunteer group to handle these things. This is a small slice of our SysOps team today. Not all 25 on-calls are there, but as you can see, we don't do hats anymore. I guess it's not very Silicon Valley. We do hoodies. So this is where we meet every Friday. It's not as ominous as it looks. None of us are Dr. Evil, but so we have a weekly meeting where we go through learnings. We have teams come in and present. We talk through them, any problems they might be having, or run books, or processes that they need improved, or they're teaching us, as well as going through the past week and maybe planning the next hoodies. I don't know if anybody's familiar with the term a yak shave. Incident response is often a yak shave. So if you're not familiar with the term, it's you go to fix something and you find something else that needs fixed first, and then before you can do that, you got to find something else that needs to get fixed, and it turns into a yak shave. And this is something that is common when you're trying to remediate issues after the fact. And so for an offsite, the team went yak shaving. This was a more fun and relaxed version of it. So where does this go from here, and how does this get formalized in something that I'm thinking of as people first on call? So asking people to go on call voluntarily isn't something that people would normally sign up for. I understand that. So how do we make the process not interruptive to somebody's life? And so I think beyond work-life balance, we need to think about pager-life balance. Not every on-call is the same as every other on-call. So you need to make sure that your engineer is right. You're not just splitting the pager around between different teams, but if there are teams that are hit more often with problems that maybe you're getting other people to come in and help out, you're growing those teams, and if this is going to be part of somebody's job, we need to make sure that we're tracking it. This is also something that we should have a growth mindset towards. We should no longer, in the same way that teams try to say that, bug fixing is important, we need to be doing that. That's just as good as launching new features. Being on, pager duty is no different than that. These are the people that are making sure that your site is staying up and reliable. And so we should see this as an opportunity that these engineers are learning, they're growing, and they should be recognized. We should also be doing more metrics collection around on-calls. So beyond just mean time to acknowledge, mean time to resolve, maybe start collecting information about how efficient were they at getting, going to the, routing it to the right team. Were they able to, use the right run books? Being able to collect more metrics to make somebody's on-call not just better for the business, but better for them. And then better scheduling. In DevOps, I don't know about you guys, but I'm on like 8 different pager duty rotations, I think right now. So as this becomes more and more of an occurrence, and as you maybe go to teams like SysOps, right, which are very important, scheduling becomes a really difficult thing. And I think this is a place where the industry could really stand to benefit, is smarter scheduling. If I'm on 4 different rotations and I'm going on holiday, I feel like our tooling should support finding the best times to make that happen. As well as if I'm having a really terrible on-call this week, maybe we need to intelligently realize that and reach out to my manager and also reach out to my secondary and swap us and get somebody with fresh eyes in there. And I think we shouldn't necessarily just say, here's our schedule for 2 years into the future and go with it. So I think there's definitely more we can be doing on the people side of things to make the process better for everyone. So I want to talk a little bit now about the tools that we use at Airbnb to make this possible. And the first one I want to talk about is Stats-D. If you're not familiar with Stats-D, there's a wonderful blog post that Etsy put out, the creators of the Stats-D protocol, called Measure Anything, Measure Everything. And this, I think, is a great mantra to have instilled in everybody's mind and makes teams like SysOps and DevOps style incident response possible. So the first tenet of Stats-D is that your metrics live in your code. You no longer need to have separate, monitoring solutions looking at your data warehouse pipeline, that every time that I am going to make a change, that you're able to increment metrics right in line with your code, and then you're able to instantly get dashboards and inspect that data. If you're launching a feature and there's not a metric next to it, how do you know that that feature is working as intended? And so having our code base, I don't want to say littered, but very carefully littered with Stats-D calls everywhere means that you're able to do, when there is an incident, you're able to do printf debugging style evaluation of your code for things that have already happened in the past, because you're able to step through, see which metrics were incremented, which ones weren't, which timers went longer, which ones weren't, and it's all already there. You don't need to go back after the fact, try to recreate it and profile it. This is also a great way that we're able to meld systems and business metrics at Airbnb. We're able to have single dashboards that have simultaneously system CPU usage, EC2 packets in, and at the same time next to it, we're able to have the number of bookings that happen per country right next to it. And this is something that we find very powerful. This means that when I get an alert, I'm able to go to dashboards and instantly understand what is the impact that this is having on our business, what is the impact that it's having on our infrastructure, and how might those two things be related. And I think, especially at the keynote yesterday, I think we've seen how different solutions to this can be really powerful in understanding what's happening. I think a lot of times infrastructure teams tend to be very focused on CPU usage, memory usage, cache hit rate, but you need to be able to take that and tie it to your business metrics to understand whether or not you really need to get out of bed at 3 a.m. to look at that page. And then I think the most important thing about Stats-D, if you haven't seen it, is that it's simple. Every engineer can do it. We have an expectation that new engineers ship code in their first week at Airbnb, and I'm sure a vast majority of those changes have Stats-D changes right next to them because it's a single line of code. You just need to give it a metric name, and you namespace it, and then it instantly starts working. You don't need to go talk to the SRE team to do a schema change to your open time series database to get your metric in there. You don't need to talk to your data warehouse team to figure out how you're going to integrate your pipeline into the streaming database exports. You're able to do it with a single line of code, and I think having that kind of simplicity is very powerful. This leads into alerts. If you haven't already seen it, Airbnb has an open source tool called Interferon, which allows you to define alerts as code. And so this is a tenet that Airbnb has, that configuration should be code, because we're engineers, and this is how we work. With Interferon, we're able to auto-generate alerts, and I have an example next. But this is very powerful because product engineers launching a new service, right? As we espouse the microservice revolution, as we go to this route, we have to make sure that all of those systems instantly have system metrics, CPU usage, memory. And so making sure that all of those things come for free is very important at Airbnb to make sure that our engineers are able to move as fast as possible. Also, Interferon is extensible. It's able to integrate with different sources. It's also able to integrate with different backends for information. So At Airbnb, we have a tool called Optica, which has information about all of our different services and who owns them. So using Interferon, we're able to query that. So when we do create alerts, they automatically get routed to the right team. And like I said, it's extensible. So right now, it's only used for StatsD internally at Airbnb, but we're also hoping on very soon extending it to support New Relic alerts. And it's on GitHub. Pull requests are welcome. So if you have any other solutions, back-end or front-ends, that you'd like, we'd be happy to take a look at the code and hopefully get it out to even more people. So this is an example of what I mean by alerts as code. So we have a repository in GitHub that engineers are able to make pull requests to, and they're able to structure their alerts as code. This is really powerful because something like this is how we make sure that all of our systems, all of our infrastructure isn't seeing any CPU issues. And you can imagine issues happen. What happens if these alerts get lost? How do you recreate them? So having this as code means that every 15 minutes, we're able to sync and be like, hey, is everything good? Are all of those alerts still there? And if not, we automatically push them. If anybody tweaks any alerts in any UI, maybe accidentally while they're looking at it, no worries. 15 minutes later, we're going to do a sync from the code that's in the repository. This also makes sure that as people are making changes, if I'm saying, hey, I want to look at when system load is above 99% instead, if I want to make that change, I need to go through your company's pull request process. I need to make a PR. I need to get it submitted for code review. And people are going to look at that, and they're going to challenge me on why I'm making this change and make sure it's good. I think oftentimes alerting is seen as secondary. But if your alerting goes down, you have no idea whether your product's working or not. So making sure that we're using the same rigor for our alerting and metrics, I think adds a lot to our trust that when we think we're OK, when alerts aren't going off, that actually things are OK. Because if anybody's made any changes to those things, we've looked at it and reviewed it. But like I said, sometimes things do happen. We use the blameless postmortem culture, like I said. But having this process isn't actually that useful unless we're able to consolidate that information, make sure other teams are doing postmortems, and make sure that we're learning from them and implementing the changes that we asked. So we have a tool internally called Incident Reporter. This is where we're able to, when we create an incident in Slack, when it starts, any open incidents are listed at the top. So if our VP of engineering wants to know what's going on, he can check out the incident reporter and see what's going on without having to scroll through Slack logs. But also, after the fact, this is where we're able to gather the impact. We're able to record how many users were affected, how many minutes of downtime did it occur, what systems were affected. And we also have a place for them to put their postmortem with a template to use to make sure that that we're following through on writing the postmortems. It also sends reminder emails if you don't get that done super fast. And then we're working on Jira integrations for follow-up. I think this is really important because as you go through the DevOps model, we have teams that are creating incidents for incidents that never bubbled up to sysops, that never got seen by SRE. And they're going to say, hey, we need to make these certain changes, right? And those are going to be prioritized. Maybe they'll get to it next quarter. But if multiple teams start having issues and the remediation items are all connected, this backend service isn't reliable enough, or this backend service doesn't scale the way we need it to, we're able to see that and reprioritize based on what kind of incidents these tasks would remediate or mitigate. Lastly, there's another tool, I'm sure you've all heard of it, called New Relic. That's used pretty extensively at Airbnb. And I want to maybe spend a little bit more time deep diving into how we're using New Relic at Airbnb to support things. So first up, I want to talk about browser. Not every engineer is a front-end engineer at Airbnb, but every engineer affects our front end. Our product is our front end. If you're making changes, you're doing it because you want to expose a feature to a user, or a user's having a bad time and you want to make it better. Everything goes through our front ends. And so having infrastructure engineers making changes leading to JavaScript errors when you don't know that that's happening isn't a really great situation to be in. So browser is what allows us to have a single place where we're able to monitor what our front end is doing. It's really great because it has the same kind of UI as APM. Every engineer at Airbnb goes through training and they understand how to use this tool. And so as you're making a deploy to any service, if it impacts our front end, you're able to come in and make sure that it's not creating JavaScript errors. It's not causing terrible degradation in your page load time. I think a lot of times infrastructure engineers are really, really tied to response time of your application server, which is great to pull that down. But if it only, if a user takes 10 seconds to actually load your page and your backend responds in 100 milliseconds, there's probably a disconnect there that you might want to understand a bit better. The other great thing about browser is that we're able to have alerts now about our front end. What we talked about before with statsd and interferon at Airbnb traditionally was only backend. If you pushed a change to a service and it started throwing null pointer exceptions, don't worry, there'd be an interferon alert that would be able to affect that. Or if payments started seeing bookings not happen, don't worry, there's an alert for that. But what happens when the book it button isn't working and there's a JavaScript error every time you click on that? Maybe an hour from now, payments might say, hey, we've seen like a 5% drop, what happened? But not being able to have other alerts or monitors tied to the front end means that it's going to take a lot longer to triangulate that issue if it's occurring at the front end. I don't know about you, but lastly, I only use Chrome. I don't think I've ever opened up Airbnb in Safari. And a lot of engineers are like that. Either maybe you only use Firefox, you only use Safari. I don't know how many people here use IE10 to look at their website. But you might have a lot of users that look at IE10. Airbnb, for example, is doing a large push for business travel. As you can imagine, there are some large companies that maybe aren't quite as far along the quote digital transformation quote unquote path that maybe are still using something like IE9, IE8, and so being able to split errors by which which browser is experiencing them is super important at Airbnb because oftentimes there might be a long tail of browsers that users aren't testing, especially if you're making a backend change, right? I don't know if somebody who's pushing a change to a memcached routing configuration is going to make sure to open up the site in 10 different versions of Internet Explorer. For example, this was an issue that was able to be caught because of browser. So this is something that was causing users not to be able to talk to hosts properly on our site. It's not a feature that a lot of people always use on this particular page. It also was completely unconnected from the change that went out. And so being able to clearly see when this happened, when it got remediated, is really important. We're able to correlate it with times to deploy. As you can see, this one was out there maybe a little bit longer than I would like. But as we are working towards integrating browser more and more, we'll eventually have the same automation that we do with APM on browser. Speaking of APM, if the Etsy mantra was metrics anywhere, and measure anything and measure everything, our APM mantra is every application, every deploy. So out of the box, any service that you create at Airbnb is going to come with APM. It's not optional. We use Chef to provision our infrastructure. And so as you say, like, hey, I need a Rails service installed on this box, you don't get a choice to say, oh, I also want New Relic. That comes out of the box. Because of that, every engineer knows that New Relic is going to be there. It becomes a tool that everybody's going to use because it's everywhere. If you're on sysops and you're an engineer from team A and you only work on service A, but there's an issue with service B, you can trust that there's going to be a New Relic APM page for service B because of the way that we've set it up in Chef. And so this allows us to have consistent monitoring across our different applications, which includes different platforms. So at Airbnb, we're mostly known for our Ruby development. Like I said, we have a large application that we refer to lovingly as the monorail. But as we move towards a more service-oriented architecture, we're seeing more and more Java services come alive. We now have Node services as well. And so being able to have a place with a consistent view into understanding the response time, where, during an application, what part of your code is it spending the time in, you're able to dig down into transactions the same way on Java and Ruby, means that a team like sysops is possible. You don't want to have to teach somebody who's spent their entire career working on Ruby how to debug this very specific application and the very specific kind of database, JDBC, code it's using to talk to its backends. So New Relic allows you to diagnose and triangulate problems regardless of what service it is. Lastly, deploying at Airbnb is very much tied to our APM usage. So there was an engineer here from Airbnb last year that talked a bit about our deploys process. So our lovingly, previously talked about monorail application. I think nowadays it's going out about 50 times a day. We're deploying Airbnb.com. Every time we deploy Airbnb.com, there's between 1 and maybe 20 different engineers' changes going out with that deploy. Engineers deploy themselves. We don't have a change release team. The SRE team isn't responsible for that. If you make a change and get it reviewed, you merge and you deploy and you monitor it. And so APM is how a process like this is possible. I don't know if I would want to have any product engineer having to go to 20 different places to understand how their change might be impacting the response time of Airbnb.com. We're able to trust that every engineer is going to have the ability to understand the lay of the land and how their change is impacting our users. This is what deploy board looks like as it's going out. This is definitely not sufficient just to look at these 3 graphs, but just to drive home the point, every single deploy boards page, as you can see, this one's for monorail, has information from New Relic on the page embedded there without an option. This is possible because every application has New Relic out of the box. As you can see, we're scaled up a little bit. We have a lot of boxes right now in preparation for our launch. The other important thing about APM is it allows kind of a consistent jargon between different teams. I don't know if your team has nightmares about the color pale yellow like I do, but I don't know if you, oh, it's there at the bottom. So Airbnb, up until a couple months ago when we started doing a large investment in our core storage team, we've kind of internally known that we often had issues with our MySQL backends. And so this was not a great, so you can see the deploy line and then maybe some not so great things happening in MySQL there. So this allows teams to say go to the core storage team and point at their APM and core storage team instantly knows why you're talking to them. Another important tool that Airbnb uses from New Relic is synthetics. Like I said, interferon, hopefully we're catching things very early. APM, hopefully people are watching changes go out. But I want to be able to sleep comfortably at night knowing that our users are going to be able to use our site. And synthetics means that even if things get through their process, there's multiple layers to making sure that issues are caught in production. So synthetics is also important because there are things that happen in between Airbnb.com and an end user. And so synthetics is doing checks from lots of different locations, and we're able to, if there are issues and they're located only in London, then we're able to talk to maybe our CDN provider and try to figure out why that's happening. Or if they're happening from everywhere, maybe you got to go talk to the person who most recently deployed. So synthetics, we have it set up for alerts. It goes through PagerDuty the same way, but it also does something else. These are strategically put throughout the office on people's desks. Normally, it's a nice, slow green, very relaxing, and this is what happens when synthetics starts firing from multiple locations. I also have one at my house. Somebody built a new version of it. There's a guy on our team that creates, builds these himself that has a light dimmer in it. That's really nice. So when your lights are off at night, it's not, waking up other people that might be around. But this is a really, great way of promoting awareness of the different tools that we have at Airbnb. So I want to maybe walk through 2 situations that have happened before at Airbnb and how we were able to detect it and then triangulate what the problem was using New Relic. So the first was a degradation in our response time from our front end, our application servers. So as you can see, there's a bump right there. Maybe we were watching this for a little while, weren't sure what was going on. Yeah, it doesn't look like it's getting better. So if we go back, you can see that that time is being spent in active record. So like I said, this is our front-end monorail. So we were able to go into the database tab on APM and figure out what kind of queries are causing this issue. And then from the database tab, we're able to dive deeply in and figure out exactly which transaction and then which database and which query was having the problem. Most importantly, we're able to figure out how does this impact our users. We saw response time degrading, but are users having a bad experience? Are there things we're going to have to go back and clean up and make sure that they're having their experience is preserved? New Relic is also a tool we use to understand impact. And here we're able to see that there was no user error impact. So they were just getting a slower experience. So using this process, we were able to figure out where the issue was. Another important thing this gives us is the slow query tool. New Relic automatically samples the queries we're sending to our databases. So if there is degradation in some percentage of your requests, you're able to go in and you don't need to start sending a bunch of traffic and replaying it. You're able to get those traces right there and able to recreate maybe locally. We're able to understand the end user impact. And like I said, we're able to use the slow query tool to recreate the regression. Another time that you might know about this is, I don't know if you heard, but like smart toasters and things tried to take down the entire internet. It was really scary. Airbnb was not unaffected from this situation. But if you get a page at 4 a.m., the Hacker News post for the attack wasn't up yet, so you really weren't quite sure what was going on. So what are we able to get from this? So this is what maybe, if you look at just the left-hand side, what I saw when I woke up at 4 a.m. With this issue. There's no deploy line, so I'm able to very quickly from the single tool. I don't need to go digging into our other tools and understand if there was a deploy. I know there wasn't. But error rate is starting to go up. Also, I guess just we're also able to, like, going back in time, understand how the different attacks affected us. There was 2 waves. The second wave, by the second wave, a lot of our external services had pushed fix, so we weren't affected. We were able to dive in and say, where are these errors coming from? We went into transactions, the transactions tab, and we were able to figure out that they were database issues. Which of our data stores was causing the issue? We were able to dig in and see it was MySQL and understand that during that first wave, we were seeing problems with connecting to our MySQL database. So if you were to dig into those errors, you would see both there was issues on the database side, but also Airbnb uses lots of external services to provide services to our users, things like Jumio, which is how we collect information about somebody's ID to make sure they are who they say they are. And we were also seeing issues there. So we were able to go in and understand that which database was having the problem. We tried to triangulate it. We weren't able to because it was every single database was having a problem. And then we were able to see that some of our service providers were having issues. And this is what allowed us to verify that it was in fact caused by the DNS outage from the attack. Briefly, as was alluded to at the beginning, there is a conference going on right now in LA called Airbnb Open. It's a conference that we put on for our hosts. Last year, there was 5,000 hosts in attendance. This year, by now, the announcement has been live. We're announcing new product features, and it's like an evolution in what Airbnb is providing for people on trips. I'm very excited for it, but I was also very nervous for it, especially being here today and not watching the graphs as they go out. But I like to think that I was a little bit less nervous because of how we're using New Relic internally at Airbnb. Like I said, every deployment of every application has New Relic out of the box. This includes development applications. So the same tools that developers are using to test their application, to do load testing, to when they push changes to make sure that they are behaving how they think they are, that tool is still APM. And so this means that as our changes, as our developers were building their tools, APM was part of the process from the very beginning. As they were pushing changes, as you can imagine, you want to dark launch some features. You want to make sure that it's taking traffic. You want to make sure that when you throw the switch, it's ready to go, and you're not waiting for your CDN cache to flush. That's really scary because you have a team that's iterating very fast on new features that they're not able to smoke test maybe in our staging environment because the code, there's nothing to look at. So how are you sure that when you push a change to a service that's not supposed to really be used until today at 10:30 a.m., but they're still being called by your front end as a dark launch, how do you make sure that that's not going to impact anything? And so using the external services understanding of APM, when somebody makes a change, they're able, if there are errors, they're able to very quickly track down which service is causing that issue. And so you feel more confident in doing dark launches because there's not going to be hidden backend services that you're not going to have visibility into that are going to cause response time degradation. Load testing is something that SREs like to talk about, but it's not something that's usually very accessible to product engineers. I don't know if you've ever looked at the output from JMeter, but it's not exactly the easiest thing to grok. But APM, like I said, is a tool that every engineer is using day in and day out, and they're able to understand how to dig into slow queries, where their response time's going, understand external services. So when we do load testing against production, we're able to use the same tools like APM to figure out how it affected the application. So if I send 10x the expected volume of queries to a backend service, and I say, hey, you're doing really well, but you have this long tail of queries that are really slow, they don't have to say, OK, well, how am I going to recreate this in a lab? How am I going to figure out which database calls were taking longer? Because that's all in the slow query log in APM, because even their staging environment has that out of the box. And then day of, we feel more confident in the changes that we're going to be making because there's people with big dashboards up as they're throwing switches. We're able to see if there's a response time degradation and we need to scale up any service. If there's other teams as the launch is going on, right, they're able to look at their dashboards for their services and see how they might be being called and what their throughput changes. So something like launches are always, there's a lot of uncertainty. You're not sure exactly how many people are going to show up, how many people are going to click on that link, how many people are going to be logged in. And so there's always going to be some audibles. And so having a consistent look across our infrastructure in a tool like APM means that other teams that maybe weren't as involved with the launch but could still be impacted are able to monitor it as it goes out. Also, personally, I feel more comfortable. Like I said, I was able to take a peek over at our dashboards just before I got on stage to make sure that the error, trust that the error rate isn't going nuts, that I'm able to trust our response time is sane and not going nuts, and that the services are being called as we expect by looking at transactions. This industry, in the study of incident response and scaling, there's some really amazing people that have laid down a great foundation that has made Airbnb able to do these kinds of processes. So I do want to call out, these are some that have really influenced me and this talk specifically. Especially want to thank the folks at Etsy, because I think they're up here twice for both blameless postmortems and for StatsD and making that possible. And with that, thank you all so much for listening to me talk this morning. I hope maybe there's some ideas or processes that you're able to take back to your teams. As long as there's not a fire when I get off stage with our launch, I'm definitely excited to stick around and maybe talk about how you guys are doing incident response and maybe ideas or processes that have worked out well for you. So thank you so much.